Okay, it says assume that the duration of human pregnancies can be described by a normal model with a mean of 263 days and a standard deviation of 18 days. Answer the following questions. The first thing is what percentage of pregnancies should last between 275 and 285 days? So that's just a regular normal DIST question that we can answer with Excel. Remember, when you want the area between, you need to do the area to the left, 285, the larger value minus the smaller value. So you're going to do equals, and you'll do the norm.dist function, and you're going to do 285, comma the mean, which is 263, comma the standard deviation, which is 18, comma 1. So that's going to return the percent of pregnancies, or the percentile for pregnancies that last 285 days or less. And then you're going to subtract from that the percentage of probability of a pregnancy to last 275 days or less. So the difference then is going to be the part in between. So you can just type that in there. Oops. Let's see, I forgot my comma. Okay, and so that's going to be 14.2 pregnancies will last in between there. Now it says at least how many days should the longest 25% of all pregnancies last? So when you're looking for the data value that's associated with a given percent, that's when you're going to do the norm inverse button. But you have to do the longest 25% is meaning the area to the left is going to be 0.75. So we'll do equals norm inverse. Oops, sorry. Select that formula, and then we're going to do 0.75, comma the mean, which is the 263, comma the standard deviation, which is 18. So we would expect it to do 275.1 days. Is what we call the 75th percentile. Now we're going to apply the central limit theorem. Part C is where we change this. Part A was really, A and B were really just parts from like what we could have done in Unit 1. So suppose a certain obstetrician is currently providing prenatal care to, here's your sample size, 90 pregnant women. We'll let Y bar represent the mean length of their pregnancies. According to the central limit theorem, what is the mean? Well, of course, you know the mean is 263 days, because the mean of a sample of 90 women is going to be the same as the mean of just one woman, or the mean of the distribution. Okay, but the standard deviation is going to be reduced by the sample size. So it's going to be 18 divided by the square root of the sample size, which in this case is 18 divided by the square root of n. So let me grab that, figure out what that is. 18 divided by the square root of the sample size, which here is 90. So that's 1.897, or 1.9 rounded to 2 decimal places. Okay, now the probability that the mean duration of these patients' pregnancies will be less than 258 days, that's going to be the norm dist on 258, but you're going to use your new mean and standard deviation. So you'll do equals norm dist, and it was, what was the value they wanted? 278? Or 258. So 258, comma the mean, which is 263, comma the standard deviation, which was the square root of 18 divided by, I'm sorry, it was 18 divided by the square root of 90. And then comma 1. We hit enter. So that's 0.004. It's a very small probability that that would occur. Let me see if I can get this to fit in here. You may just have to trust me. Come on. So 0.004. Okay.